Hey y'all, welcome back to Alakazam Math Made Easy. In the last video, we went over a little bit more about a higher derivative, kind of as a teaser for something we'll go over in a couple videos later, but just know that that could technically be a question on a lot of your exams, asking to find like the fourth or fifth derivative, or how many derivatives you have to take for it to get to the second, or like a second order function, or like zero or something like that. So that's what we went over in the last video, but I realized we haven't gone over one of like the central functions to a lot of math, right? And that's trig. So we have to consider what those derivatives might look like. And lucky enough, there's a set of rules, just like there was for exponential functions, logarithmic functions, there's rules that these follow. So again, this is going to be something that, unfortunately, as much as I hate to say it, you are probably going to have to memorize. But we'll start by going through them, right? So sine x, the derivative of sine x is cosine x, the derivative of cosine x is sine x. So honestly, the hardest thing to remember between these two is where the negative sign is. So remember that negative sign. And then another one that you're going to have to know pretty well is tangent, right? And tangent becomes secant squared x. So my honest recommendation is to memorize only these four, because those are the ones you're going to use the most often. And sometimes a lot of professors like to maybe throw in a question about these two just to confuse you. But a lot of times the four that you'll need to know and the four that you'll use the most often are these four here. And the benefit of knowing these four is obviously sine and cosine, you're going to have to know those are the most common ones you'll use. Tangent and secant are related, just like cotangent and cosecant are related, but I'll go into that in a second. So tangent becomes secant squared x, and secant becomes secant x tangent x, right? So that's the pattern there. Basically, that just says that those are related. But if you look at, for example, tangent x and cotangent x, oh, I wrote this wrong. There we go. If you look at these two functions, what do you notice is in common, right? So these two are technically, you could call like opposites of each other, right? Tangent and cotangent. And secant and cosecant are also opposites of each other, right? They're still both squared, but the one thing that's different is this negative sign here. So for cotangent and tangent, think it's opposite functions and cotangent's negative. So opposite functions, opposite signs. You can go with that. Now let's look at, for example, secant and cosecant, right? So again, these are what we could consider opposite functions, secant, cosecant. And let's see, we have secant and cosecant again, tangent and cotangent again, and we have that one negative sign. So again, you could remember opposite functions, opposite signs. And that's how you can remember just these four, but also very quickly obtain these other two, right? So I would remember just those four, and then remember opposite functions, opposite signs for the ones that you haven't remembered yet. But again, that's honestly just going to be like a flashcards kind of thing. I'll make a Quizlet and link it in the description of the video, so you have access to one that's already pre-made, so you don't really have to have, you don't have to do a lot of work about it. But I would 100% remember these, because very rarely is a professor going to put on an exam or a quiz any kind of like, okay, here's sine of x, what's the derivative? No, they're going to combine it with the stuff that we've already gone over. They're going to combine it with product rule or quotient rule or some version of those combined, right? So that's what we're going to jump into right now. So in this top example, I fly through one together, or I fly through one that's written out before we do one, and we'll go over one that's more complex together, right? And it goes over, it's a nice review of obviously trig functions, but also it's a nice review of a complex version of product rule. So again, product rule is just the first one, the derivative of the first one times the second one plus the first one times the derivative of the second one. So that's exactly what we did here. So 10 sine x became 10 cosine x, and then we left x squared the same. And then again, 10 sine x is left the same, and then x squared becomes 2x. And then we can simplify by pulling out a 10 and an x. So that would become 1. That would just go away. So that's where this simplification came from here. So let's do a more complicated one together. So remember how we approached the three function product rules before. So we broke it up into first 2 functions, where one function is second, like the combination of the 2. We broke that one up into, we'll call it A and B, right? So like normal, so y prime is going to equal the derivative of the first one. So what I'm going to do is I'm going to write that part in purple, and that's going to be the derivative of this whole piece here. So that's going to be 4x e to the x, where e to the x is just left alone, plus 2x squared e to the x, and that is just the derivative of e to the x. And then what I'll do is I'll say that is plus, that's times, this whole quantity is times secant x, because remember it's the derivative of u times v, and then we're going to do plus the derivative of v, which is secant x tangent x, times u left alone, 2x squared e to the x. So then what we can do is simplify, right? So as always, we simplify. In this function, we have a secant and a secant. So why don't we pull that out first? We also have at least a 2 in common, and we have an e to the x in common, and we have 1 x in common. So let's do 2 secant x e to the x times x, and that leaves us with 2 in this term. It leaves us with x in this term, plus x, plus, so let's see, plus tangent x times x. So let's see, y prime, we'll clean this up a little bit so it's easier to read. So it's 2x e to the x times secant x. And that's times, I believe that's times, okay, yeah. So then it would be x plus 2 plus x tangent x. And that's the simplified version. So remember, with a function that uses product rule but has 3 functions built into it, the product of 3 functions instead of just 2, what we're going to do is we're going to break up the whole function into 2 sections, but one of those sections is going to have 2 pieces in it, and then we'll break that up, and when we take the derivative of part u, we're going to do a second product rule with the 2 functions inside of it. So we'll do a similar thing with the trig quotient rule. And the way that we'll go into the example we're doing together is that there's actually 2 ways to solve it, an easy way and a hard way. And we'll go into, I want to go over the easy way because we've already done an example of a product and quotient rule combined. So before we jump into that, for the example we went through together, so remember it's low, which is the cosine, so that's where this came from, times the derivative of the high, so we're going to take the derivative of this whole piece, and that just works out to 4x, minus the numerator left alone, times the derivative of the denominator, which remember goes to negative sine x, and then this part is just the denominator squared. And what we're going to do is we're going to simplify. So remember, if this is a negative and a negative, this term is going to become a positive, so that's important to remember. But other than that, it's really just cleaning it up, making it look nice, because it's hard to cancel complex functions like that. So this one I want to go over together. We've done an example of a, what's it called, a product rule and a quotient rule together kind of problem. And that's technically what this is, right? You could do low D high And then the d high, you're going to have a product rule, right? Because that's two functions that can't be simplified or combined. But what I want to look at is a simpler way to do this problem, right? So you have e to the x sine x over cosine x, but because these are like pretty like central functions, not like they're one of the six, right? There's sine, cosine, secant, cosecant, tangent, cotangent. They're one of those six. And usually those six can be rearranged to equal each other. And that's the case for this. So that would be equal to e to the x times sine x over cosine x, sorry. And that's the same thing as saying e to the x times tangent x. So this became a problem associated with quotient rule because there was a fraction, but we simplified it to one that actually is a product rule problem. So let's do this again. So this is going to be u, this is going to be v, but again, now there's only two problems or two terms, so that's actually much simpler. So we're going to do the derivative of u, which is that, times v left alone, plus the derivative, u left alone, sorry, times the derivative of v. And what we'll do is we'll simplify that by factoring out an e to the x, and we'll do tangent x plus secant squared x. And that's our answer. So we saved ourselves a lot of time by going through and trying to condense a lot of these trig functions, but know that if you didn't think to look for that, you could go through the whole other process and get the same answer. So don't freak out if you didn't notice that, but if you get on a time crunch and if you get to one of these, I don't know why I erased that. If you get to one of these problems and you want to save some time, especially on an exam setting where it's a timed environment, go ahead and try to find this simplification or find a similar simplification. But like I said, it's not critical to solving the problem. So that is a summary of derivatives of trigonometric functions. You'll find that they end up being applied to anything else we've talked about for derivatives so far. So it's super, super important to remember these rules. Like I said, I will make a Quizlet so you have access to that in a few days, but the bulk of you should have that access at the time you're seeing this video. So if you learned something like this video, if you would like to ask a question, drop the question in the comments. I'll answer it as soon as I can. If you want to stay up to date with the videos that I post on this channel, subscribe to it and press the notifications button so that you get notified when I add stuff. And as always, best of luck.